Hello, this is Rolf O'Grady with Mocana. I am the Vice President of Customer Success at Mocana, and today I wanted to just share some experiences I've had working with our customers and prospects in the marketplace. And today I was really looking to maybe provide some perspectives, if you will, on the differences between IT and OT. It's not so much that there's confusion between the two, but rather I think some challenges associated with folks bringing an IT mindset to try to address challenges in the OT space. So that is a basis for the conversation today. Looks like we have some folks joining. We're about 1:30 into it anyway, so from that, let's just get started. And for folks joining late, they can obviously go back and look at the recording. I kind of already introduced myself, but I guess I should add that the bulk of my career has been in predominantly IT or information technologies, data communication, and security. So I too came in with a mindset or perspective, or maybe I was looking through the security challenges in operational technologies with an IT mindset, or like I said, looking through that lens. And while some of the principles definitely apply and are absolutely usable in the OT space, I have found that some of those technologies, processes, and tools that we have at our disposal in that space really are ill-suited for addressing challenges in the OT space. So that's the bridge I was trying to start building here today. So I'm a huge fan of taxonomy, and different folks tend to use different acronyms in particular in different ways. So just wanted to hit the four main ones today, and I pulled this off of Gartner's website. But for me, IT, I tend to also oversimplify things, but in my mind, IT is really, the reading, writing, processing of data for the purposes of conducting commerce or operations, whether it be in education, healthcare, et cetera. But ultimately, here I've got end users that are entering, creating, reviewing, modifying data as a part of a business process. From an operational technology perspective, now we lose the concept of a user. Now we've got headless devices, but these headless devices are also connected to networking environments. Those networking infrastructures may vary from market segment to market segment, but basically now we have devices that are plugging into an environment that are doing discrete functions, whether it be in a factory, a power plant, a hospital, a refinery, on an automobile. But here we now have devices that are executing a function or a physical task, providing data either in the form of metrics coming off of said device, or sometimes as a Boolean yes, no, I open the valve or I close the valve. IoT, from my perspective, is really the commercial side of the Internet of Things, or at least that's where I tend to bucketize it, if you will. This is more really largely driven by consumers, end users. This is where we got devices in the home, tablets, mobile phones, and certainly with the introduction of, or proliferation rather, of 5G gateways, this is going to include pretty explosive growth. IIoT, in my mind, I differentiate a little bit in the sense that these are IoT devices, or an extension of IoT devices, but these really tend to be deployed in more partially siloed or siloed environments. I've got a software framework that wraps around them for the purposes of managing, monitoring, measuring what's happening in those environments. But these are really built for purpose devices. And one of the challenges here is just the sheer number of devices across this type of ecosystem. The number of hardware platforms, the number of operating systems. Some of these devices don't even have an operating system. Some might have a microkernel. But the complexity index of I shouldn't say the complexity index. Well, it is a complexity index just due to the sheer number of devices and device types. But one of the things I think folks, or at least this is the way I look at it, but for me, one of the first questions I have is, what's the price of failure? Because ultimately, security ends up becoming a cost-risk equation that a customer needs to work through. What's the cost of security, or what's the cost of compromise or breach in my environment? And this is, for many folks, actually a difficult equation to work through. but certainly price of failure, if you will, from an IT perspective, I mean, granted those can be pretty severe, but they tend to manifest themselves in the form of lost revenue, financial penalties if I'm not adhering to a specific standard or a governmental requirement, and likely a potentially very large brand hit, which could also go back to revenue or loss of sales. In an OT environment, certainly there is also the concept of financial impact, but in my mind, and probably more importantly, now we're talking about an impact to human experience, and not just human experience, but potential loss of life. So the stakes are much higher, and one of the other just higher level business challenges I see is that risk equation is difficult to it's not so much the calculus, it's the challenge. It's where is the spend for security taking place? And today it's still predominantly in the IT side of the equation, and that's really a function, in my opinion, that really is a function more of the general philosophy that security is important, but not at the impact of my ability to conduct commerce. So as a result, the spend in security tends to be more lopsided in IT. But we're starting to see that obviously grow in OT. And then the last bit there is, who are the folks that are trying to compromise these systems? In IT, general statement, but these are bad actors that are doing this for either financial gain. Maybe they're doing it for political reason. Maybe they're doing it just for the sake of demonstrating that they're capable of doing it. And like I said, that's a general statement. On the OT side, depending on the market segment, now we start talking about nation-state attacks, literally cyber warfare, and how do we combat those types of environments. So going just back to the IT security side of the conversation, do we lose the presentation? Oh, sorry. Help if I looked at the right screen. Apologies for that. So as we talk about IT security, we have not even general. I guess the first comment here is my experience in IT security is basically it's a battle you can never win. You're always playing defense, and you're always trying to get to a security posture that's either good enough or reasonable enough or manageable enough to at least ascertain what your current risk posture is. And then we've had, technologies that we've been using to solve those problems. I mean, from a networking perspective, doing things like VLAN, segmenting traffic, micro-segmenting traffic, analyzing traffic on the wire, doing protocol traffic analysis, using IDS, IPS systems, doing anti-malware stuff on the host, whether it be antivirus or anti-malware detection. And then one of the things that we'll tend to use from the host perspective is also things like isolating a host or for remediation. In an OT world, now we've got other paradigms that we need to adhere to or use, but physical security, physical premise security now becomes a major question. Now, the other challenge is also how are we going to deal with devices that are either completely air-gapped or partially air-gapped. We have safety processes that we have to adhere to in those environments. And then probably more important, not probably more importantly, but very importantly is once an incident takes place, how are we going to respond to that incident? In the IT world, if something happens to my laptop and it gets compromised, well, I just go to the IT desk and they either give me a loaner or they fix it while I wait. I don't have that luxury in a production environment. I have to be able to remediate either on the fly or via a technician that's going out to deal with a device. And then if I just look at the number, the big challenge around operational technologies is just the sheer number of devices, platforms, and operating systems someone has to deal with. In an IT world, I don't mean to trivialize it by any stretch, but I mean those operating systems and platforms tend to be fairly finite or low in number. Might be a Windows, Mac, OS 10 shop from the user perspective, Windows, Linux from a service or application delivery perspective. I mean, the number of platforms and operating systems are far smaller. As I was saying, in an OT world, the device type and platform operating system requirements is far broader. The other challenge is in an IT world, we basically have humans interacting with a device. It's not the same in an operational technology environment. These are, once again, completely headless devices, so I need to really start thinking about what am I going to do with that device? How am I going to verify its identity? How am I going to authenticate legit traffic from illegitimate traffic? How am I going to protect data at rest, data in flight? How am I going to secure communications between devices that have, they may have just a very light IP stack, or maybe they're barely able to do DTLS, but how am I going to do encryption between devices? So once again, just if I look at just the devices that are out there, and I tend to think about this in kind of four main buckets. The first one is really what I'd call a brownfield or legacy devices. These are ones that they may not even have a microkernel, or maybe they have a microkernel, but this is something that's going to be a very low-powered device. Well, not low-powered, low headroom, or a low capability relative to what the device can actually do above and beyond its own critical core function. But the point here is I might have the luxury of a lightweight IP stack. I might have enough memory to handle a key or certificate, but not much more. And then another bucket would then be devices that are a little bit more, have some more resources available, but they're still pretty limited in nature. These will typically have a microkernel, maybe an additional microcontroller, a secure element. Here and now I see more capabilities in the form of doing some encryption between devices, but I'm still challenged from a headroom perspective on the device. Third category would be, I kind of put this in a greenfield device category, but these are kind of emerging devices in this market segment. Devices that have, a real-time operating system, whether it be FreeRTOS or VxWorks. It could be Linux, Android, Windows, IoT, Windows 10. But these are net new devices that are coming into the market and or may already be deployed. But here I'm starting to see things like hardware or secure elements, whether it be TPM, EPID, SIMs. But now we've got an ability to actually leverage something that's on the device to enhance the authentication identification of the devices. Then the fourth category would be edge gateways. And I'm not really fond of the term gateway because it means different things to different people. My definition of a gateway in the OT space is really a device that's going to have a physical connection to a public or private network, but ultimately there's going to be a presence on a transport network. On the back side of that, it's probably going to have some, not proprietary interfaces, but non-standard interfaces, whether it be CAN bus, Modbus, Zigbee, whatever is going out the back end to communicate with the devices behind it. But ultimately, I've got a platform that's going to have strong or a lot of headroom in the form of operating system, flexibility, a lot of memory, a lot of storage. It gives an opportunity to do more with the device. But once again, then there's the devices behind that gateway which still need to be addressed. And then the obvious challenge is also the fact that, okay, now I've got devices that are inherently insecure. They're running an IP stack, but now we're also starting to see these devices or traffic from these devices, whether it be data traffic for an application or whether it be command and control traffic. Ultimately, these traffic patterns are now being transported over those or shared IT networks or resources. So this obviously creates a major problem because now I'm inserting basically a lot of insertion points or threat vectors for a network that I've already spent a significant amount of time and effort trying to secure. In an IT world, here we obviously see a lot of things in the form of trying to do real-time analysis, threat detection, analytics. These are absolutely critical and important. We need to measure, monitor these metrics basically for the proper maintenance of the environment. But fundamentally, I guess where I'm going with that whole thing is that's easy to say, but difficult to do because the protocols and devices that exist in the OT world are once again, very diverse and very widespread. So trying to do real-time analytics becomes difficult. So my argument is protection is by far more important than detection. Not to minimize the importance of detection, because that is critical, going back to the need or requirement to be able to measure, monitor, and maintain an environment. But ultimately, protection becomes, to me, the first step in securing these devices. So if we can provide a high level of protection, or we can basically harden these devices to make them very difficult to be compromised in the first place, it really drastically brings down the need to do real-time analysis and detection. One of the other challenges or areas that needs to be understood is just what is the chain of trust? And that's another term that tends to get not misused, but used frequently. But for me, there's chain of trust and there's the root of trust. Chain of trust is, in my perspective, from the time a legitimate piece of software is created, and hopefully it's gone through some analytics to verify the legitimacy of the software, but ultimately, from the time that software is created to the time it actually lands on the device, a fair number of entities are going to be touching that artifact in some form, shape, or fashion. From the development release team all the way through the technician that's potentially plugging a USB stick into a device, that's going to go through a lot of hands. So understanding who touched that artifact, at what point in the provisioning process, as well as being able to tightly control that artifact becomes critical. Because if I've got a device that I have the luxury of touching once a year, that needs to be a very high value touch. And whatever I put on that device, I need to have a high level of assurance or certainty that that is a known good piece of whatever, code, firmware update, configuration file, script, whatever it is that's landing on that device, has a high level of authenticity, so I can increase my confidence level that the device is not going to be compromised. Because the worst possible condition is that I have a device that gets compromised, which is persistent across a boot. At that point, the only thing that can be done is just a device or a hardware replacement at that point. So, now that it painted a bleak picture, I'd kind of maybe go back and just categorize some of the areas of concern that I've heard from customers. I mean, one of the probably more frequent challenges I hear is just, and the intent is not to denigrate or bash OpenSSL, but I mean, it has its challenges, as an example. So, you know, with patches that need to be applied, updates that need to be applied, the impact that may have to an application that's using it becomes a challenge for many companies. So there's just the concerns around the hidden vulnerabilities associated with open source tools. We're starting to see containers much more frequently now in the OT space. So very common now to see containers doing discrete functions on a device, or an application that's running in a container on a device. But ultimately, it really comes back to how am I going to successfully or safely update the container and application once it's been deployed on the device. I've added another element of complexity to the device I need to be concerned about. Probably one of the more common areas that I see all the time is I've got a bunch of devices that are leaving the factory, or I've got a bunch of devices that are in the field already, and those devices may have a common username and password. They may have a pre-shared key. The challenge there is obviously if I crack one, I crack all of them. So that becomes a major concern. So how do I address that problem either at the time of manufacture, and there's the opportunity going back to, you know, installing or implementing a rigorous chain of trust. But if I can put a birth certificate on the device when it leaves the factory, now I've got an ability to uniquely identify a device, and importantly, make sure or assure myself that it's not a clone device once it's landed in the field. Because one of my other concerns is, all right, now I've got a device that's in the field that I am reliant on the data potentially coming from that device. Can I trust that device? Do I even know if that device is mine, or is that a rogue or clone device sending inappropriate data back to my command and control system? Embedded malware, we're just talking about that a moment ago, but if my device gets compromised and that compromise is persistent across a reboot, I have a major problem. So the only way to recover at that point is to basically replace the device altogether. So those are just some general areas of concern that customers have expressed. If I look at that kind of more from a market segment perspective, I mean, from a healthcare perspective, as an example, for me, this is probably one of the greater challenge areas, because this is where I tend to see the most overlap between IT and OT systems. We've got devices in a hospital that are connected either via wireless or Ethernet, but they're IP-based systems, but some of these are serving critical functions like monitoring someone's heartbeat or breathing, or basically touching the patient in a pretty significant way. But once again, that traffic and access to that device is over a shared medium. So how do I address challenges in that marketplace? In the process automation, the industrial segment, the market segment, I mean, this is literally, the challenge here in my mind is just really around just the sheer number and types of devices and the spectrum of capabilities that those devices have. We also see a lot of industry-specific or proprietary protocols. These devices tend to be pretty open and insecure, and for good reason. I mean, these devices are intended to be deployed in an isolated environment, but yet those isolated environments are now starting to be connected back to common networks. So how do we now bring security to devices that are typically, woefully open and insecure? Transportation and aviation, challenges there are obvious in the sense that those devices are extremely mobile. The time or the frequency with which, or the connectivity I have to those devices, to those environments is a big question mark. The expectation is at best the device is probably going to be partially or infrequently connected, or it might be connected over the air, which creates some other challenges about reliable transport. But there are a lot of devices and systems on those platforms that need to have frequent updates. I mean, we've got control units, things that control speed, onboard diagnostics, navigation systems. Ultimately, there's a lot of devices in that environment that require frequent updates. In the aviation space, similar challenges apply, but what we see here is also an industry that is kind of using some fairly outdated delivery mechanisms to get to those systems. And certainly from an impact to compromise, here we're definitely talking about, as well as healthcare, well, actually in a lot of these segments, potential impact to human life or loss of life. Media and entertainment, another market segment here where it's, with the explosion of 5G, proliferation of IoT devices in the homes and in the enterprise. I mean, one of the big challenges here is, really more than anything around data privacy. How am I going to make sure that these information systems are not impacting a user's data privacy? Let's see what else. There's one other I wanted to talk about. Oh, and defense is another market segment. Here we're definitely talking about impact to loss of life. So how do we secure these systems where, once again, now we have very, very specific purpose-built platforms serving very highly critical functions. So how do we secure those devices and the transport of traffic across those? The energy market segment, here it's, this is impact to the human experience, and certainly probably one of the more likely points for a nation-state attack. So how do we secure those environments? If I look at the challenge in a little bit more of a horizontal perspective, who are the people or who are the constituents in those verticals that have some common challenges? If I look at the chip vendors themselves, certainly in some of these market segments, especially healthcare now, military, defense, there's becoming a high reliance of establishing a strong chain of trust in the manufacturing process. but also embracing, a strong hardware root of trust on the device itself. So leveraging TPMs, EPIDs, SIMs, as I mentioned earlier, but establishing that strong root of trust at the chip level and making sure that as the different components are going through the manufacturing process, how are we uniquely identifying this and controlling who has access to those elements? From a device manufacturing perspective, if I'm shipping a device out and I'm taking multiple inputs from different chip vendors, from different software vendors, how do I ensure that the device, once it leaves my factory, is in a hardened state? How do I ensure that it's got a birth certificate that I can leverage later for either doing inventory management or verifying proper ownership at time of deployment? I may need to do things around licensing from a customer perspective. I may want to have the ability to revoke a certificate if I need to cancel a license. But stated another way, how do I make sure that I can uniquely identify these devices so I once again have a high level of assurance that it is indeed my device and not a cloned device? From an owner-operator perspective, some of the things we see here is, well, I guess one of the concerns is around how do I manage these devices? So most folks don't want to necessarily get locked into a cloud platform or a service provider. See the need or desire rather to basically buy protection versus building it from scratch. So how do you drop something on the device to create an initial security posture and then provide a mechanism for doing true lifecycle and security lifecycle management of the device through the device's life. From a service provider perspective, this goes back to the probably more of the challenges around device onboarding. How am I going to make sure that I can uniquely identify these devices? And then not only do I need to make sure I can uniquely identify these devices, but how do I ensure that these devices are not cloned and causing a loss of revenue? Can you go to the next slide? Sorry, there we go. So this slide, we're basically going to bring it home from here, I guess. So what are the benefits that we see, or the benefits that we can offer in the marketplace to try to help solve some of these challenges? So one of the first, as I was just referencing, was how do we help with the hardening process for devices as they leave the factory? So we can help with the challenge associated with ensuring that code that's destined for a platform, whether it's operating system, firmware, and application, is known good code. We can track who touched it at what point during the manufacturing of that device, and then also provide a birth certificate when that device leaves the factory. So going back to addressing the challenges around a pre-shared key or common username and password, which is nice to say, but how do I do that at scale? So providing a back-end capability to basically do this authentication of devices and provisioning of devices at a very large scale, or how do we help with challenges associated with zero-touch provisioning? I want to deploy a gateway at a site that's going to be in a hostile environment. It's going to be deployed by an untrained person. How do I bring that up? Because that device has probably been sitting on the shelf for a while, but how do I bring that up, make sure it's running the latest version of software, make sure that proper keys and certificates are applied to the device, make sure the application that's running is the latest version, make sure that connectivity is established and tested at the time of deployment. These are all things that we can help with as far as the onboarding and provisioning process goes. Going back to, sorry, I lost my train of thought. What was I going to say? Oh, so just on the device side itself, once the devices are in a deployed state, how am I going to take now updates that need to be applied to those devices over time? One of the big challenges that we constantly hear from customers is a lot of these devices, once again, are either air-gapped or they're sitting in an isolated network, and commonly either an untrained technician or a reasonably trained technician is going to be doing or executing the update process. So how do I make sure that an image that's sitting on a USB stick that someone's plugging into a USB port on a sensitive device is the absolutely approved image that is destined for that device and nothing else is going to land on that device? So going through that entire supply chain to the time of code drop or firmware update or configuration update to the devices is something that we can help with as well. Once devices are under management, how do I provide control access to and from that device? If the device should only be doing outbound communication, well, it'd be nice if I could control inbound TCP or IP requests. Or in an environment, and we see this in healthcare and in the industrial segment, but we see a lot of devices that are communicating over either multicast, broadcast IP, unicast IP. So how do we provide a mechanism to deliver encryption between those devices or between the device and a control station? And then how do we also do that in a brownfield environment where some of the devices I mentioned earlier won't have the horsepower to do encryption in the first place? So how do we help with the challenge of making sure that these devices are secure and tamper resistant in a hostile environment, and that the data between, or the command and control traffic or the data traffic is encrypted between the devices or between the devices and the command station? This is another area that we can provide some assistance. There's another challenge around just how do we do the updates, or how do we help with the update process? As I mentioned a couple of times now, we need to frequently update these devices from the operating system perspective. They need to do firmware updates. One of the newer common challenges that we were running into, no, you shouldn't even say newer, just becoming a more frequent request from customers, which is, hey, I've got a TPM on the device, but I'm not using it. I'd like to be able to use that, or I'd like to be able to leverage the TPM, or I'd like to have my application leverage certificates. So how am I gonna do a light to no touch addition to these devices to help with that challenge? This is another area that we can provide a lot of help with. And then, just from a resiliency perspective, or more from an assurance or attestation perspective, if we can help a customer with the challenges associated with leveraging the secure elements on the device, we now also have a platform and a reporting mechanism to help the customer with the attestation requirements that they may have for those devices in these given environments. So there's a lot that we can do across the spectrum of devices. It's interesting, as I speak with customers and prospects, I try not to sound defeatist, but one of the first question I ask is, there's a lot we can do, but the question I ask is, what does the distribution curve of the devices look like in your environment? Because I have a high level of confidence that we can provide a tremendous amount of value across a broad range of devices, but ultimately the devices themselves need to have the headroom and capability of supporting the features and capabilities that we're able to deliver. But even in a restricted environment, going back to devices that, like I said, may not have a lot of horsepower, there would be a huge benefit, as an example, if I could just, once again, if I could just verify that, yes, this is a device, it's a known device, I'm able to do a strong level of identification, authentication of that device. I can increase my confidence level in the data coming from that device is legitimate. If there's a little bit more headroom, we can help with challenges around encrypting data in flight or encrypting data on the device itself. But one of the common, well, I don't know if fallacy is kind of a strong word, but one of the common expectations is, hey, my stuff's encrypted, so I'm good. And I'm not going to argue the point. I would actually argue, yeah, absolutely, you need to encrypt data at rest, data in flight. But in my mind, cryptography is only as strong as the keys that I'm using, the algorithms that I'm using, and more importantly, the frequency with which I'm rotating them. So if I've got small keys or short key lengths, then I got to have a high frequency of key rotation. Otherwise, I've got fairly vulnerable systems out in the wild. So in short, that's what I wanted to speak of today, I'm looking up at the board to see if any questions have come up. I'm assuming we're posting the, yes, I'm sorry, I should read the question. Can you send slides out to us after the talk? The answer is yes, absolutely. We'll post it on Bright Talk. That was the second question as well. Oh, I wish I would have been looking at this earlier. Now you can skip that one. I've already gone through that. Yes, several questions about asking to get the slide deck, so happy to do that. Did you? Oh, sorry, there was another question that came up. Yeah, so I've been loosely chatting about a back-end service that we provide. So think of the solutions that we provide as kind of a client-server model. So we've got bits that can reside on a device, and there's a spectrum, as I was saying earlier, of what we can provide from a pre-built binary to custom code that we can develop and deploy on a platform with a customer or with a vendor. That's a very broad spectrum. Trust centers are the back-end services then that really empower the client-side technologies. So from the enrollment perspective, providing secure updates I've been alluding to, doing the key and certificate management on the devices, that's a platform that we call Trust Center. It's basically a container-based platform. So whether a customer wants to run it in a public cloud, we here at Mocana, we run it, our instances in AWS. I should probably also qualify the fact that we are not as a service company. We run it in Amazon strictly for doing demonstrations, proof of concepts, and field trials. But the point is, we've got it running in AWS, so we're pretty much cloud agnostic. And then on the physical premise side, there's the ability to either run portions of Trust Center in the cloud and running portions of it physically on-prem, or running the entire Trust Center platform on-premise or in a private data center. So it's pretty flexible as to where Trust Center can be deployed. And then, I'm not sure the exact nature of the question, but around compliance. So there's some inherent information that we're providing as part of the end-to-end solution. So things like how many devices are currently identified, how many have been updated, when's the last time devices were updated, what updates did they receive, what updates are they waiting for, what certificates are currently deployed on the device. So we can help with providing information to a customer around that side of it. And then as we go forward, there's also the promise of being able to do device monitoring. We've got it working on a couple of platforms, but ultimately, how do we help with information coming back from the device itself? A lot of these devices are really pressed for memory, so they don't really have good mechanisms for doing any kind of logging. So how do we provide information back to an AI or an ML system for analytics around what's happening on the device itself? Let's see. Sorry, I'm just looking at the questions that are coming in. For limited computing resources like IoT devices, how will you conduct authentication and integrity checks on sensor data? I don't think PKI is a reliable solution with certificate management. Yes, that goes back to the first question I asked are what are the devices currently deployed and what capabilities do they have from a platform or from a chipset perspective. The short is, I mean, there's some devices out there that are literally going to be extremely Boolean. I mean, is the valve open or closed? I mean, it's just going to be a printed circuit board potentially, so there's not much we're going to be able to help on that side. So it really becomes a question more of what capabilities does the platform have? Given that, what's the level of capability that we can help provide? Do they have threat intel subscription in Trust Center? Oh, so yeah, so this sounds like, do we have the ability to do threat feeds in the Trust Center? The short answer is no. We're not doing real-time analytics. We're not doing any antivirus type stuff. As I said at the start, our goal is to how do we help a customer protect the device in the form of controlling the supply chain, so ensuring that what gets on the device is only what's supposed to be on the device, and then hardening the device and make it as close to tamper-proof as we can. So yeah, we're not focused on doing real-time analytics on the device. That said, going back to what I was saying, the information that we can provide back, both as our monitoring solution evolves and becomes more mature, the data or the events that are coming back from the device, whether it be in the form of reporting on the update process, whether it be in the form of analytics coming back from the monitoring process, these are all signed, encrypted events. So the level of assurance on those events is extremely high. So if we're feeding into some, like I said, back-end analytics platform, AI or ML systems, the level of authenticity of those events is very high. Can you elaborate on the remote monitor and recover? Yeah, so going back to what I was saying earlier, so I really blew past the enrollment and update process. The enrollment process is where we uniquely identify a device, either at the time of manufacture or at the time of deployment, or post-deployment when we put bits on the box, so to speak. So this is where we, well, let's just say we digitally fingerprint the device based on some number of parameters that a customer wants to do that with. But ultimately, we fingerprint the device in the form of keys and certificates that are unique to the device. What that then allows us to do is either revoke a certificate to take the device out of commission, or provide a secure mechanism for us to basically re-image the device. So if the device is determined to have malware running on it, we can securely re-image the device, which would help with the challenges around, the challenges of having to roll a truck to fix a problem. Sorry, I was trying to answer a question while I was reading the next one. It caused a minor cord dump. Apart from Intel, is ARM supported? Yes. I've lost count of the number of hardware platforms that we've tested on. I would say it's well over 70. So ARM, yes, not a problem. Can customer registration authority be used for certificate management with KMS or key management? Yes. The short answer is yes. We are not a certificate authority. I don't like to use the term broker, but what we do is provide a mechanism to allow a customer, probably more, I don't know if it means so much a end user customer, but this is probably more in the manufacturing realm or the operator realm, but the ability to map commercial certificate authorities or like Microsoft, depends on whatever the customer is using. Let me back up a second. So, well, like one of the common challenges is healthcare as an example. If I'm a medical device manufacturer and I'm selling into the medical space, these devices are going to go into a hospital or a clinic. That clinic or hospital is likely a part of a healthcare chain, but that healthcare organization is likely going to be using either a public CA or a private one. So how do I as a medical device manufacturer put a birth certificate on the device and then transfer ownership once it lands into these different environments? So the entire system is built to be pretty flexible as to mapping a device or group of devices to a customer, or based on group of devices to a specific certificate authority. So it's very flexible in that regard. Did you say this is going to hard stop at 45 minutes? Okay. So let me just pick up one more question here. Not really sure I understand that question. Do you have any partnership with national labs in designing, developing security? Sorry, I should read this more clearly. Do you have any partnership with national labs in designing, developing security technologies such as device authentications and secure command and control patents? To my knowledge, no. I'd be stunned if we haven't spoken with them in the past. I do know that we have generated several patents in this realm. That's something I'd have to look at. I don't know the short answer to it. I do know that Mocana, the company, has been around for quite a long time, and we've been doing a lot of source code and library type work with a lot of different entities. I know in the earlier days of Mocana, we did a lot of partnerships. So I don't know the short answer, yes, no, on national labs, but I would be shocked if we had not done some work with them. All right, with that, let me wrap it up. I wanted to do a commercial, I guess. So going back to the earlier question, so the recording will be obviously posted, as will the presentation itself. And I touched on the very tips of some different market segments. So we have another webinar coming up on March 25th. And that webinar will be focusing, I shouldn't say focus, well, we'll be focusing specifically on industrial IoT devices and getting deeper into the security on those devices, as well as the compliance requirements in that market segment. So look forward to that one coming up on March 25th. And with that, I will bring it to a close. So I want to thank everyone for your attention. Certainly been nice to speak with everyone. It's always odd speaking in an empty room when you're talking to yourself, but I do thank everyone for the participation and the questions that came in, and look forward to speaking with you all again in the near future. Thank you.